Hello guys, welcome to the first episode of Tea Time Psychology.
We focus on IB psychology, and today we'll be diving into the Maguire et al. Study that took place in the year 2000.
Today we'll be going through some of the background information of the study, details about the study itself, and an evaluation and a summary of what we've talked about. Quick disclaimer, we're not professionals, and therefore this cannot be used for any type of diagnosis or professional setting. This is simply for educational purposes, and regarding sources of the materials we've used will be linked in the description box below. Now, back to the tea.
Okay, to begin with, the hippocampus is something very important within this study.
And what's the hippocampus again?
The hippocampus is located in the temporal lobe. It holds short-term memories and transfers them to long-term memory storage. Maguire had a theory that the hippocampus has a role in enabling spatial memory in the form of navigation, and wanted to find out if it can change in response to the environment.
Right. Another concept that you should be familiar with for this study is gray matter. It is part of the brain's neural tissue and refers to areas of the brain containing a high concentration of neurons, and this brings us to the term neuroplasticity.
Yes, neuroplasticity. In our brains, there are neurons, which are nerve cells that send messages all over your body. These link together into neural circuits, which are interconnected to form large-scale neural networks. Neuroplasticity is when these networks change by making new connections and reorganizing themselves as a response to changes in the environment, experience, learning, or even an injury.
Also, the theory of localization of function is an important thing to understand. This refers to the theory that different parts of the brain correspond to different functions, such as thoughts, behaviors, or emotions.
So, a study was conducted in which people with experience of spatial navigation, in this case London taxi drivers, were asked to participate. They had undergone a considerable amount of training focusing on spatial navigation, known as the knowledge, for an average of 2 years. This study, which we'll be talking about today, is by Maguire et al.
Now let's start off with the aim. The aim of this study was to examine the brain structure of individuals with extensive experience of spatial navigation as opposed to a person with less experience.
And also the detection of structural changes was examined using an MRI machine.
As for the methodology, the study used an independent measures design where participants were either in an experimental group, being a London taxi driver with more than 1.5 years of experience of driving, or the control group consisting of non-taxi drivers.
Yeah, and both groups are healthy right-handed males at an age range of between 32 to 62 years. The mean age not differing between the two, but the number of participants varying. The condition group had 16 participants, whereas the control group had 50.
A structural MRI was then taken of the 16 taxi drivers, and they were compared to the MRI scans of the 50 control subjects, which were taken from a structural MRI database from the same unit as taxi drivers were scanned.
Now for the results. The experiment showed that an increase in grey matter was found in the left and right hippocampus of the taxi drivers. The most significant increase in volume was found in the right posterior or rear hippocampal region.
Actually, when looking at the data, a positive correlation was found between the amount of time spent as a taxi driver and the volume of the right posterior hippocampus. However, it was also found that the anterior or frontal hippocampal region was larger in the non-taxi drivers.
So, what did the researchers conclude from the study?
Well, they concluded that this evidence seems to suggest that there are structural differences between the hippocampi of London taxi drivers and the control group.
Right, and this implies that more experience with spatial navigation affects the hippocampus in terms of neuroplasticity.
Exactly. The hippocampus adapted to the environment by making new connections, hence the changes in gray matter. It's even possible that a mental map of London is stored in the posterior hippocampus, which leads to an increase in tissue volume.
And the results can also be related to a localization of function, right?
Definitely. We can see that very specific areas of the hippocampus seem to increase in volume as a result of navigating around London. These areas, such as the right posterior region of the hippocampus, may correspond to a function, which in this case would be spatial navigation.
Anyway, what was good about this study?
Well, some strength of the study was that many extraneous variables or variables that can affect the outcome of the study were controlled. For instance, the mean age, genders, and right-handedness was all kept the same.
And also, the 50 control participants' brains were taken from an MRI database at the same unit where the taxi drivers were scanned, which means the same MRI scanner was probably used as well.
Right. What about weaknesses?
Well, a main weakness was that since the MRI scans of the control group were taken from a London hospital, ethical issues are raised about consent and use of data. Also, the sample of 16 male taxi drivers is very small. But when looking at the results, do you really think that they show cause and effect?
I'd say they seem to only show a correlation, not causation. I mean, the taxi drivers' brains weren't scanned before and after, only after. So it's possible that people with a larger posterior hippocampus are attracted to careers that target their spatial abilities, such as taxi driving.
But what about the fact that there was a positive correlation between number of years spent driving and volume in the right posterior hippocampus?
Oh yeah, that would technically also counteract that argument. But there's something else on my mind. Why did the posterior hippocampus change more on the right side with these right-handed drivers? Isn't it strange, since the left part of the brain generally controls the right side of the body?
Yes, what we really need is a follow-up comparison with left-handed drivers, possibly mainly female this time, and a much larger group. So that question seems to remain unanswered.
I think it's time to summarize what we've been talking about.
Yes. First of all, Maguire's study comparing the brains of taxi drivers and non-taxi drivers found that the size of certain areas of the hippocampus, which is involved in spatial navigation, increased in taxi drivers.
On the other hand, while the right posterior regions increased in size in the experimental group, the anterior region was actually larger in the non-taxi drivers.
One conclusion was that neuroplasticity possibly had a role, since the hippocampus adapted to the environment.
However, ethically speaking, the researchers took MRI scans from a brain bank without asking for consent, and the sample was also very small and only male, meaning that the results cannot really be generalized.
We hope you've learned about the Maguire et al. Study.
And if anyone's wondering about what tea we've been drinking, it is Gold Keely's natural ginger tea bag with lemon, and we've been drinking it because we're both sick at the moment.
We are not sponsored, by the way.
That's all for today. Thank you for joining in, and congrats on having an attention span longer than a YouTube short. Bye!
Bye!